Welcome, students. Today we embark on a fascinating journey into the realm of circular motion. It is a captivating concept that involves objects moving in curved paths, such as a spinning top, a car navigating a bend, or the moon orbiting around the Earth. Let's dive into the principles of circular motion and unravel its mysteries. Circular motion occurs when an object follows a curved path with a constant radius. To understand and analyze circular motion, we need to introduce a few key concepts. The first concept is centripetal force. Centripetal force is the force that acts toward the center of the circle, continuously changing the direction of an object in circular motion. In circular motion, an object experiences an inward force directed toward the center of the circle. This force is responsible for keeping the object on its curved path. Without this force, the object would move in a straight line, tangential to the circle. The centripetal force can be provided by various factors, such as tension in a string, gravitational attraction, or frictional forces. It is important to note that centripetal force does not act alone. It is a result of other forces, such as gravitational force or friction, that provide the necessary inward force. For example, when you twirl a ball on a string, the tension in the string provides the centripetal force that keeps the ball moving in a circle. The second concept we introduce in circular motion is centripetal acceleration. Centripetal acceleration is the acceleration experienced by an object moving in a circular path. It is always directed toward the center of the circle and is perpendicular to the object's velocity. The magnitude of centripetal acceleration can be calculated using the formula A equals sign V2R, where A represents the centripetal acceleration, V represents the velocity of the object, and R represents the radius of the circular path. One of the key observations in circular motion is that the speed of an object may remain constant, but its velocity is continuously changing. Since velocity is a vector quantity that includes both magnitude and direction, any change in direction results in a change in velocity, even if the speed remains constant. This change in velocity is what gives rise to the centripetal acceleration. We can further explore circular motion by examining the concept of angular velocity. Angular velocity is a measure of how quickly an object rotates or revolves around a central point. It is the rate at which an object covers an angle as it moves along its circular path. The unit of angular velocity is radians per second. The relationship between linear velocity and angular velocity can be understood using the equation V equals sign, or where V represents the linear velocity, omega represents the angular velocity, and r represents the radius of the circular path. This equation highlights that objects farther from the center of the circle must travel at higher linear speeds to maintain the same angular velocity. Understanding circular motion allows us to comprehend a wide range of phenomena, from the dynamics of rotating machinery to the behavior of celestial bodies. It provides insights into the principles behind amusement park rides, the operation of centrifuges, and the motion of planets and satellites.